I would actually like to start with a question. Those people who work in news recommender systems, have you had meetings with editors who try to put in editorial values and journalistic principles into the news feed? Yes. How pleasant were those meetings? I didn't hear that, so, sorry. So with DRDW, our goal is to present an algorithm that naturally incorporates, or that focuses to incorporate norms and values from editors and from the newsroom. The main idea is we want to make this as easy as possible. So what you see on the top right is what we call a normative target distribution. The idea is an editor can sit down and say, okay, if we have a news feed, I want to focus on topics. I want the news feed to contain so and so many, let's say, political topics and so many sports topics. So this is a way for them to kind of, on a very high level, curate what a news feed that the recommender algorithm puts out could look like. This is just one sample for topics, but you can have various item attributes like sentiment and so forth. Our main motivation in this process is the work that is on the democratic role of news recommender systems, where they say that recommender systems are really essential when it comes to inform the public about news, and they should be actually infused with some norms and values. And we took this and said, okay, one of the approaches is, if you have something like political topics, one way to infuse norms and values is to diversify. So you don't only want to hear about one political party, you want to hear about all the political viewpoints. And to that end, we use random walk algorithms. So random walk algorithms is a group of algorithms that create a bipartite graph, where you have on one side the black dots, you have the readers, on the right-hand side with the red dots you have articles, and then you can hop between readers and articles, and the recommendation you get are articles that are very close to you. And in the past, it has been shown that this actually leads to very good diversification results, and is also a very lightweight approach. Now, DRDW is based on random walks, on those normative target distributions, but it is kind of a complete algorithm pipeline. So in the first step, we have the pre-processing stage, where we actually have or our implementation helps you to create the graph, the underlying graph. It also has some ways to deal with cold items. You saw on the previous slide that in order for an item to be in the graph, it needs to have a reader. If you have a new item where there are no readers, it's a bit, you're in a little bit in trouble. So we provide functionality to calculate an article embedding. So you look at a new article, you compare it to your archive, and then you sample the 5 or 3 most similar items, and then you say, okay, those 3, 4 similar items, we connect the new item without readers to the readers of the 3, 4, 5 most similar item, and that way you can get an augmented graph that serves as an item pool. Then in the second stage, we actually have a random walk procedure. You can define how many hops between you and the target item there should be. And then, of course, this is where our magic or our secret sauce, the normative target distributions, come into play, where you can have all those high-level decisions of the editors of the newsroom that's kind of serve as a filter to look at the output of the random walks and then to sift through the items and see what to keep and what to throw out. Finally, once we have the candidate list, there is a pre-processing stage where we actually re-rank the item. You can have some business logic, and at the end, we provide or create the recommendations. Now, this is all nice and good in theory, but in our paper, we also run some benchmarks on the EBNERD dataset from last year that focuses on use recommendations. And we compared our DRDW implementation with state-of-the-art random walk model RP3beta and some state-of-the-art Microsoft recommender algorithm LSDUR and NRRS. And if we look at the calibration, this is how similar are the recommendations of our algorithm versus what the user read in the past. We actually see that DRDW, while it diversifies, it also kind of keeps very close to what the user read in the past. So the lower the calibration, the better our match of their past reading history. If we look at fragmentation, this means, so a large value in fragmentation means every user kind of is in their bubble, reads the articles, and only they see the article. Low fragmentation value means that there's kind of a shared item pool that your entire user base reads. We actually also see that with DRDW, so the fragmentation goes back. We see that more and more people engage with more and more content. Gini, so baseline diversity metric, we see that we actually achieved the lowest Gini value. So if you look at party, this means that we very much have an equal distribution of all the parties in the political space. Sorry, that was the wrong button. Interlist distance, we also saw, so the higher the value, the more different articles are. So we not only recommend articles that cover all the parties, we also achieve best scores in terms of articles that are different from another. So people don't just read copies of one and the same article. Finally, compute cost, we see that, so if we take RP3beta's baseline, we see that we are 4 times as expensive, yes, but still cheaper than the neuro baselines, which are 100 plus times more expensive. So yes, DRDW, an easy way to incorporate norms and values, performs excellent on a very large range of diversity metrics. Paper, code, tutorials, everything is online for you to download. We published everything as open source. And if you want to know more and how to put this into practice, stay tuned for the second to last talk. Thank you very much.
Normally, diversifying happens in the last ranking stage. Why do you do it earlier? How do you balance diversity and user preference or personalization?
So the thing is, the later you do the personalization or put in norms and values, the fewer items you have to work with. So ideally, you do it as early as possible in the recommendation stage. And so that is why we put everything as early as possible.
There are lots of different norms and values. What specifically did you implement in your experiment?
Yes, so we followed the guidelines of Natalie Hellberger, which has an excellent paper on kind of the democratic role of news recommender systems. And one model she proposes kind of a deliberate model. So a deliberate model for news recommenders is one that kind of puts equal emphasis on all, let's say, political positions, such that people kind of know what actors are there in the political space. They come to know what opinions exist. And then the hope is that this sparks a kind of conversation. People get together, kind of know what is currently up to, what are the current issues to discuss and so forth. But of course, this is just one example we did for our offline evaluation. And there are numerous other ways on how you can tweak and customize this to your own needs.